Have you ever bought two items that looked identical in the store, only to find they don't match under different lighting? It's a common experience that can be quite puzzling. This phenomenon is known as metamerism. It's a fascinating aspect of color science that often catches us off guard. Imagine buying two black socks under bright store lights. They look the same. You're confident they match perfectly. But at home, under your regular lighting, one sock looks black and the other looks navy blue. How can this be? This is not a trick of the light, it's science. It's called metamerism. It's a reminder of how our perception of color can change based on the lighting conditions. Metamerism happens when two colors look the same under one light source but different under another. This can be particularly noticeable with items like clothing, paint, or even makeup. This is because of how objects reflect light. The light source plays a crucial role in how we perceive color. Different light sources, like sunlight or fluorescent light, have different wavelengths. These wavelengths interact with the objects around us in unique ways. Objects absorb some wavelengths and reflect others. The specific wavelengths that are reflected determine the color we see. The color we see is the reflected light. So next time you notice a color mismatch, remember it's not just your eyes playing tricks on you. It's the fascinating science of metamerism at work. Understanding metamerism can help us make better choices when buying items that need to match, especially under different lighting conditions. It's always a good idea to check colors in various lights before making a final decision. Embrace the science, and you'll never be caught off guard by mismatched socks or any other items again. We need to understand how we see color to understand metamerism. 4 things are involved: the light source, the object, the observer, and the brain. The light source emits light. This light hits the object. The object absorbs some of the light and reflects the rest. Our eyes are the observer. They detect the reflected light. The brain interprets the signals from our eyes as color. This whole process determines the color we see. It's a complex interaction between physics and biology. Metamerism happens when objects reflect light in unique ways. This phenomenon occurs because objects reflect light differently based on their surface properties and material composition. Think of it like a fingerprint, where each object has its own distinct pattern. Every object has a unique reflectance curve, which is essentially a graph showing how much light the object reflects at each wavelength. This curve is crucial in determining the color we perceive because it varies with different lighting conditions. When two objects have different reflectance curves, they can appear identical under one type of light, but look completely different under another. Imagine two objects, A and B. Under daylight, they both reflect the same amount of green light, so they both look green to us. However, the story changes when the lighting conditions change. Under fluorescent light, object A might reflect more blue light than object B, altering its appearance. This makes object A look slightly bluer than object B. This shift in color perception is what we call metamerism. Metamerism is not just a scientific curiosity, it has practical implications in industries like printing, textiles, and even automotive design. Understanding metamerism helps in ensuring color consistency across different lighting conditions, which is crucial for quality control. So next time you notice colors shifting under different lights, remember it's metamerism at play, revealing the hidden complexities of light and color. This fascinating interplay between light and material reminds us of the intricate beauty of the world around us. Metamerism unveils the hidden layers of our visual experience, making us appreciate the subtle nuances of color in our everyday lives. Metamerism is a fascinating phenomenon that affects various industries in unexpected ways. Metamerism is a big deal in many industries. It's not just a minor detail, it can have significant implications for quality and aesthetics. Car manufacturers need to worry about it. When producing vehicles, ensuring color consistency is crucial. Imagine a car with different parts painted to match. Each part might look perfect under factory lighting. Under the factory lights, everything looks perfect. The controlled environment ensures uniformity, but under sunlight, the colors might not match. Natural light can reveal discrepancies that were invisible indoors. This would not look good. A car with mismatched paint can be a major issue for both manufacturers and customers. The fashion industry has to think about metamerism too. Designers and retailers face similar challenges. A dress that looks amazing in the store might look different at home. The lighting in the store is designed to enhance the appearance of the clothes. The lighting in the store is different from the lighting at home. This can lead to surprises when you try on the dress in your own environment. This can affect how the colors look. Understanding metamerism helps industries ensure their products meet customer expectations in any light. Luckily, we can manage metamerism. We can use special tools to measure the color of objects very precisely. These tools are called spectrophotometers. They measure how much light an object reflects at each wavelength. This information helps us predict how the color will look under different light sources. Another way to manage metamerism is to use materials and dyes that are less likely to cause problems. By understanding metamerism, we can make sure that colors look the way we want them to, no matter the lighting.